At first glance, Neptune might seem like a cold and quiet planet, but beneath its blue clouds, something extraordinary may be happening. Scientists believe that deep within its atmosphere, intense pressures could be transforming carbon into diamonds, causing them to literally rain down through the planet's interior. In this video, we will explore the fascinating science behind this shimmering phenomenon. Neptune is the most distant planet in our solar system. Because of its location, it has not been studied nearly as much as Jupiter or Saturn. In fact, it's only been visited once by NASA's Voyager 2 spacecraft back in 1989. All the close-up images we have come from that single flyby. Neptune takes 165 years to complete one orbit around the Sun, and sunlight takes more than 4 hours to reach it. From Earth, it's so far away that it's completely invisible to the naked eye. Neptune is classified as an ice giant, but that does not mean it's filled with frozen water. In planetary science, ice refers to heavier molecules like water, ammonia, and methane, which likely existed in solid form when the planet first formed. Unlike Jupiter and Saturn, which are mostly made of hydrogen and helium, Neptune contains a higher proportion of these heavier materials, especially methane. That methane is what gives Neptune its bluish color. It absorbs red light and reflects blue. Beneath its visible atmosphere, Neptune likely has a layered structure. Scientists believe it has a solid core, possibly made of rock and metal, surrounded by a thick, slushy mantle of water, ammonia, and methane ices. Above that, the outer envelope is composed mostly of hydrogen and helium, with trace amounts of hydrocarbons. As you descend through these layers, the pressure increases dramatically. The deeper you go, the more compressed everything becomes, until the atmosphere behaves more like a fluid than a gas. These extreme pressures play a key role in the processes happening deep inside the planet. Scientists have speculated for decades that deep inside Neptune, conditions become extreme, temperatures reaching over 6,700 Celsius, and pressures millions of times greater than Earth's atmosphere. In fact, the idea of diamond rain on Neptune was first proposed even before Voyager 2 visited the planet in 1989. Based on early models of Neptune's interior, researchers predicted that methane could break down under high pressure, freeing carbon atoms to form diamonds. Under these conditions, methane molecules break apart. Hydrogen atoms separate, and the remaining carbon atoms start to bond into long chains, which then compress into diamond crystals. These diamonds, being far denser than their surroundings, would sink deeper into the planet's interior. As they fall, they could reach even hotter regions that vaporize them, causing the carbon to rise and the cycle to begin again. In essence, a constant storm of falling diamonds may be occurring beneath Neptune's clouds. Unfortunately, confirming this theory directly is nearly impossible. Sending a probe deep into Neptune's atmosphere with current technology is not feasible. So instead, scientists recreate similar conditions in laboratories here on Earth with the help of an unlikely material, polystyrene, the same plastic found in disposable coffee cups and styrofoam packaging. Why polystyrene? Because it's a hydrocarbon, just like methane, made only of carbon and hydrogen atoms. Methane is a simple gas with 1 carbon and 4 hydrogen atoms. Polystyrene, on the other hand, is a solid polymer made from repeating styrene units. Both share the same fundamental building blocks, but on vastly different scales. Polystyrene is stable, solid, and much easier to handle in laboratory conditions than methane. In one groundbreaking experiment, researchers targeted a tiny polystyrene sample with a powerful laser. The laser generated extreme heat and pressure, briefly replicating the intense environment deep inside Neptune. The plastic turned to plasma, and the shockwave compressed the remaining material. Under that pressure, the hydrogen separated from the carbon, and the carbon reformed into nanometer-sized diamonds. These lab-made diamonds only lasted a fraction of a second and were microscopic. But Neptune's crushing interior maintains those extreme conditions continuously. Over time, much larger diamonds could form and rain through its mantle. Of course, this wouldn't be the brilliant cut gemstones we are used to on Earth. Neptune's diamonds would likely be rough, jagged, and unpolished. Still, the evidence is compelling. Based on lab experiments, computer models, and our understanding of Neptune's chemistry, diamond rain is no longer just a theory. It's likely a real, ongoing process beneath the planet's surface. And perhaps the most surprising part, one of the tools helping us understand this cosmic phenomenon is not a $1 billion probe, but something as ordinary as a plastic coffee cup. Thank you for watching Planet Spiral. Please like this video and subscribe to this channel, and I will see you in the next one.